Srimati R. Padmavati, Head of Department ECE, Dhanalakshmi Srinivasan College of Engineering and Technology, Chennai. She pursued her Bachelor of Engineering in Electronics and Instrumentation Engineering at the National Engineering College, Kovilpatti. She then went on to work as a technical editor in Domix Technical Information Private Limited, Chennai. She then pursued her Masters of Engineering in Applied Electronics at the Satyabama University, Chennai. She is currently pursuing her PhD in Anna University, Chennai. She has published several national and international journals and has attended many conferences. Her areas of interest include linear integrated circuits, digital electronics, electronic circuits, VLSI design.
Welcome to UGC's lecture series BSc Applied Electronics Semester 3. Today's module is we are going to discuss about the operational amplifier as the topic. The contents of the operational amplifier, about the operational amplifier, internal circuit of an op-amp, working principle in both open loop configuration and in closed loop configuration, and transfer characteristics of an operational amplifier. About the introduction, the operational amplifier, in short it is op-amp, is a DC coupled voltage amplifier with a very high voltage gain. It consists of number of amplifier stages which are interconnected in a very complex way. It also consists of transistors, FETs, resistors, capacitors. It occupies very less space and it is available in small package in a form of integrated circuit. The operational amplifier is called as op-amp. Why it is called so? Because it is doing operations like addition, subtraction, integration, differentiation and amplification, etc. And so it is called as operational amplifier. The very popular operational amplifier we are using in the practical sessions as well as we are going to study with IC741. This has 8 pins normally. Also it is available in 14 pin package. The pin details of the operational amplifier is given in the slide. So it is 8 pin package. The first pin is for offset null. Second and third pin is for inputs. The second pin is for inverting input terminal and the third pin is non-inverting input terminal, and the output is 6th pin, and we have to give 2 supply source for the 7th pin positive supply and for the 4th pin negative supply, and 5th pin is for offset null. This pin is used for giving input offset voltage to make the output 0 when the input is 0. This is the symbol of the operational amplifier. It is a triangle shape and 2 are the inputs V1 and V2. We have to give it to the positive terminal and the negative terminal. If the input is given to the positive terminal of the operational amplifier, then the output is in phase with the input signal. And if the input is given to the negative terminal of the operational amplifier, the output is 180 degree out of phase with the input signal. Regarding the power supply of the operational amplifier, when the operational amplifier has to work, we have to give the power supply. We know that the supply terminals are 2, 7th pin and 4th pin. We have to use dual power supply. So to the 7th pin, we have to give the positive terminal of one of the power supply and the negative terminal of the same power supply must be grounded. And to the 4th pin, you have to give the negative terminal of the other power supply source, power supply, and the positive terminal of the same supply to be grounded. This is shown in the diagram. And next is the internal circuit of operational amplifier. It has 4 stages. First 2 stages are differential amplifier circuit, which is going to provide high voltage gain and high input impedance. This is the very basic necessity of an operational amplifier. If it has high voltage gain, then the amplitude of the output is very maximum even if the input voltage is in the range of nanovolts or in millivolts. And if it has high input resistance, the loading problem will not be an issue. So you can use a very low voltage as a signal. So the amplifier will be the output of the amplifier will be a magnified output. And the third stage is a buffer and the level translator. This buffer, which is nothing but an emitter follower, which also produce a high input impedance, and this does not act as a load to the previous stages. And why it is called as buffer is it is also having low input impedance and it does not affect the preceding stage and the succeeding stage of the circuit. And a level translator, why it is used here is the differential amplifiers or directly coupled without any capacitors. So the level shifter adjusts the DC values of the circuit so that the output is 0 for the 0 input. And the last stage is the output stage, which has low output impedance. So these are the basic necessities of the operational amplifier to be work in proper way. And the internal circuit also consists of drift compensation circuits and frequency compensation circuits. Next is about the working principle of the operational amplifier. As we see in the contents, it is working in the open loop configuration as well as in the closed loop configuration. First we will see the open loop configuration. So here there is no feedback, so it is a open loop configuration, and in the circuit if you see, the input is given to the negative terminal, that is the AC signal as input is given to the negative terminal number 2, and the reference voltage is given to the positive terminal number 3. So this input signal is compared always with the reference voltage, and the output is either positive saturation or negative saturation. And this input signal is given to the negative terminal. So whenever the input voltage is higher than the reference voltage, the output is negative V saturation. And whenever the V reference is higher than the input voltage, the output is positive V saturation. And if we note down the output, it is either plus V saturation or minus V saturation. And what are the saturation values? The saturation values are slightly lower than what the supply is given to 7th pin and 4th pin, that is the supply voltage. Slightly lower than the supply voltage is said to be the saturation voltages at the output. This circuit in open loop configuration, the outputs is plus V saturation and minus V saturation, and so this circuit is called as a switch. Either it is on state or in off state. So on state refers the positive saturation value and off state refers the negative saturation value. So in open loop configuration, the operational amplifier is acting as a switch, or otherwise you can call it as a comparator circuit, because the input signal is getting compared with the reference voltage given to one of the terminals, and so the output gets transition whenever the input signal intersects the reference voltage. It is also shown in the graph. So the input signal is crossing this V reference. So until this point, V reference is higher and the input signal is lower. So since the input signal is given to the negative terminal, and since it is lower, the V reference magnitude of the V reference is higher, so the output voltage is positive until that point. And after that, the signal voltage is very high than the reference voltage. Since the signal voltage is given to the negative terminal, the output is negative V saturation until the signal voltage is lesser than the reference voltage. So if the reference voltage is high again, the reference voltage is given to the positive terminal, and so the output is positive V saturation. And this will repeat for every intersection of the input signal with the reference signal. And if the input signal is given to the negative terminal of the operational amplifier, this circuit is otherwise called as inverting comparator. If we give the signal to the positive terminal and if the reference is given to the negative terminal, then the circuit is called as non-inverting comparator. So in that case, the input signal is given to the positive terminal. If it is higher than the reference voltage, then the output will be positive saturation, and if the case is reversed, then the output will be negative V saturation. Just we have to reverse this voltage levels and the reference voltage and also the output for non-inverting comparator, and this is for inverting comparator we have seen in the PPT. And this is about the open loop configuration of operational amplifier. So finally, in open loop configuration, the operational amplifier is acting as a switch, or you can say that it is a comparator circuit. It is going to produce only the positive saturation and negative saturation at its output. And next is closed loop configuration. In closed loop configuration, we are giving some part of the output signal is fed back to the input terminal. So at that point, the input signal is also simultaneously given to the input terminal. So input signal as well as the feedback signal is given to the input terminal, one of the input terminals, and this is a simple circuit as an example for the closed loop circuit. So this R3 is the resistor through which the output, some part of the output is given back or fed back to the input signal, and to the same input terminal the input signal V1 is also given, and to the next terminal V2 is given. So here this is a circuit which is called as a differential amplifier circuit. This is an example of one of the examples of closed loop configuration, and here the voltages are given to both the negative terminal as well as the positive terminal, and the magnitude of the voltages are compared. Difference is calculated, and this difference is going to be amplified at the output, since it is a differential amplifier circuit. And we all know that if the feedback is given to the negative terminal, and it is said to be a negative feedback circuit, and if this feedback is given to the positive terminal, and this is said to be a positive feedback circuit. Now in the differential amplifier circuit, when we see the diagram, the output is given to the negative terminal of the input of the operational amplifier. So it is an amplifier first. So we know that if the negative feedback is used, then it is an amplifier. The positive feedbacks are used in an oscillator circuits. The output of this differential amplifier circuit is the amplified term of the difference between these two inputs, and this amplification factor is decided by the resistors connected externally to the circuit. So this is the output of the differential amplifier. V out is plus or minus closed loop gain into the difference between the signals. Why here plus or minus is given? In the formula, in the output equation, the plus or minus signal is given. Why it is given is the difference may be positive side or in negative side. So based on the difference, the output will be obtained, and this is the transfer characteristics of the operational amplifier. So this graph shows clearly about the output of the differential amplifier. So in the x-axis, the difference between the two signals is plotted, and in the y-axis, the output of the differential amplifier is given. So if the difference between two input signals is positive, then the output is in the first quadrant, positive. So when the difference is very high, the output will get saturated. If the difference is low, then the output is linearly increased, and if the difference is higher, then the output is saturated. And if the difference is in the positive region, the output will be present in the positive quadrant, first quadrant. And if the difference is in negative region, the output is again linearly increased in the third quadrant, that is in negative region, and also it is saturated for the higher difference in the input voltage. This is clearly shown in the graph, and this is said to be transfer characteristics of the operational amplifier. And this is one of the output of the differential amplifier circuit, which is shown here. So this clipping part is shown because if the output is saturated, then in the sine waveform also the peak voltage will be clipped away. Let us have a small break. Welcome back after the break. Ideal characteristics of operational amplifier. The first is infinite voltage gain to have a maximum output, and next is input resistance should be very high. It must be infinite ideally, and output voltage is very low, 0 ideally. So if the input resistance is infinite and output resistance is 0, then it produces optimum output at its output terminal. And infinite bandwidth, 0 noise, common mode rejection ratio must be infinite, and the power supply rejection ratio must be 0. This inverting amplifier is one of the example of closed loop circuit. As in the name suggests, it is an amplifier. We have to give a negative feedback to the input terminal. Some part of the output is fed back to the negative terminal of the input, and so it is a inverting amplifier. So the input signal is given to the negative terminal, and the positive terminal is grounded here. When you see the circuit, the input signal Vin is given to the negative terminal and the positive terminal is grounded. Some part of the output is fed back to the negative terminal through the resistance R. So before going to see this inverting amplifier, we have to make two assumptions. The current drawn by the input terminal is 0, and the next one is the difference between the voltage present at the two input terminals must be also 0 because virtual earth concept is assumed here. So V1 must be equal to V2 here. So the difference between these two voltages must be 0 because these two nodes are virtually common or virtually imagined to be common. So these are the calculations of the gain of the inverting amplifier. So when you see the circuit, the current flowing through the resistance Rn is assumed to be I, and the same current will be flowing through the resistance Rf because there is no current drawn by the input terminal of the operational amplifier. So if you calculate the current I, it is Vin minus V2 divided by Rn, and the current flowing through Rf is V2 minus Vout divided by Rf. So what is V2 here? V2 is 0 because based on the assumptions we made, the voltages at these two nodes must be 0. Since the positive terminal is grounded, this negative terminal voltage at this point is assumed to be 0. So substitute V2 is equal to 0 in the equation. So you will be getting Vin by Rn is equal to minus Vout by Rf. So when you calculate the gain of the amplifier, the output voltage divided by the input voltage is minus Rf by Rn. So this negative sign indicates 180-degree phase shift between the input voltage and the output voltage. So here this is an inverting amplifier. If Rf is equal to Rn, what happens to the circuit? It is going to be just an inverter, inverting buffer you can say. So the input voltage is 180-degree out of phase with the output voltage, and the voltage is not going to be varied, only the phase is getting varied. So you can say that this circuit is a inverting buffer if Rf is equal to Rn. And next is non-inverting amplifier. So what do you mean by non-inverting amplifier, and what is the difference between the inverting and non-inverting amplifier? If the signal is given to the inverting terminal of operational amplifier, then it is always an inverting amplifier. When we see in the comparator also, if the signal is given to the inverting terminal and reference is given to the positive terminal, then the comparator is said to be inverting comparator. Same way, in an amplifier, if the signal is given to the positive terminal, then it is a non-inverting amplifier, and it is an amplifier, so you have to give some part of the output as a feedback signal to the input. And since it is an amplifier again, the negative feedback must be given. So this is shown in this circuit here. So input signal is given to the positive terminal and some part of the output is given through the resistance Rf to the negative terminal of the operational amplifier. Again we have to calculate the gain of the non-inverting amplifier circuit. So this is the circuit to calculate the gain of the amplifier. So here Vin is given to the positive terminal and the negative terminal is also virtually with the same voltage, and it is considered as V1. As in the case of the assumptions V1 and V2, the voltages at the positive and negative terminals must be equal. The same concept is applied here. So we are considered this V1 as the voltage across the resistance R2. So first calculate what is V1. So using the potential divider rule. So V1 is calculated as R2 divided by R2 plus Rf into Vout. So from this, the gain of the amplifier, we can say that Vout by Vin is equal to 1 plus Rf by R2. It is the gain of the non-inverting amplifier. So here, if we make the resistance Rf and R2 is equal to 1, 1, as in the case of the inverting amplifier, we cannot say that this non-inverting amplifier is going to produce the gain as 1. It is not going to give you the voltage as the input voltage, because the gain is always greater than 1, because in the output equation we are seeing that it is 1 plus Rf by Rn. But in the case of the inverting amplifier, it is minus Rf by R1. So if we make Rf is equal to R1 or R2 in this non-inverting amplifier, we are getting the gain more than 1, because in the output equation it is 1 plus Rf by R2. It is always greater than 1. But in the inverting amplifier, you can say if Rf is equal to R1, then the gain is 1, because the formula is minus Rf by R1. So just it is going to invert the input signal. Here in the case of the non-inverting amplifier, there is no positive sign in the output, because it is a non-inverting amplifier. It is not going to invert the input signal. It is going to only amplify the input signal. So the output is in phase with the input signal here. Next is the voltage follower. It is derived from the non-inverting amplifier. So how the voltage follower is derived, and what is the meaning of the voltage follower from the heading itself? It is going to follow the input, that's all. The output is going to follow the input signal. Output voltage is equal to the input voltage. And how we will derive from the non-inverting amplifier circuit? If we see the formula, it is 1 plus Rf by R2. What is voltage gain? It is V out by V in. So if this part Rf by R2 is 0, then we can get V out is equal to V in. So how can we make this as 0? See here, if Rf is equal to 0 in the circuit, we are making Rf as a short circuit, and if R2 is equal to infinite, we are making the R2 path as open loop. If it is infinite, we are considering that path as an open loop circuit. So if the circuit becomes like this from the non-inverting amplifier, what is the output? V out will be equal to V in, that's all. So from the non-inverting amplifier circuit, we are deriving the voltage follower. This voltage follower is otherwise called as unity gain feedback circuit, because V out is equal to V in. If you calculate the gain, it is nothing but 1. So it is a unity gain feedback circuit, and it is having high input impedance. Also the non-inverting amplifier has high input impedance, since the signal is given to the positive terminal directly. So the internal input impedance is the impedance of the circuit in the case of the voltage follower also. So we have discussed today about the inverting amplifier, non-inverting amplifier in the working principle of operational amplifier in the closed loop circuit, and in the open loop circuit we have discussed the comparator, inverting comparator and non-inverting comparator. Otherwise we can say that it is acting as a switch, and ideal characteristics of the operational amplifier and the transfer characteristics of the operational amplifier. To know how much you have understand about this lecture, we have some questions here. So why operational amplifier is called so? The operational amplifier is called so because it is performing all the arithmetical calculations like addition, subtraction, integration, differentiation, log, antilog, etc. So it is called as operational amplifier. So what is the difference between the positive and negative feedback circuits, and where they are used, and where the positive and negative feedback circuits are used? Positive feedback circuit, some part of the output signal, if it fed back to the positive terminal of the input, then it is a positive feedback, and this positive feedback is used in an oscillator. And negative feedback circuit is the reverse. The output is fed back to the negative terminal of the operational amplifier, then you can call it as a negative feedback circuit, and this is used in an amplifier circuit. What is a unity feedback circuit? Just now we have discussed. It is a voltage follower circuit. In voltage follower circuit, the output is same as the input. V out is equal to V in, so the gain is 1. So it is a unity gain feedback circuit. What is the importance of this voltage follower circuit is it can be acting as a buffer, because it is going to transfer the input voltage at its output terminal without any loss, and it also has high input impedance. It is not going to provide a loading problem for its preceding stage because it has a high input impedance. So this is the main point in voltage follower circuit. It can be using as a buffer. And next is list some of the ideal and the practical characteristics of the operational amplifier. So we have seen only the ideal characteristics. You have to say what are the practical characteristics. So ideally we can say all the values are 0 or infinity. So what may be the practical values? For 0 you can say it is low, and for infinity you can say it is high. So what are all the values infinite and what are all the values 0 ideally for the operational amplifier? So input impedance is infinite, so for the practical value it is high. CMRR is infinite, for practically it is high. And power supply rejection ratio is 0, practically it is low. Output impedance is 0, practically it is high. Similarly, you have to say other characteristics also. Design a suitable amplifier for the gain 10 and minus 10. So what do you know about this design? So I have given two values, 10 and minus 10. For 10, what is the amplifier you will design, and for minus 10, what is the amplifier you will design? I didn't say an inverting amplifier or a non-inverting amplifier. From the gain itself, you have to know which is a non-inverting and which is a inverting amplifier. If gain has minus sign, you have to design negative or inverting amplifier. If the gain is plus, then you have to design a non-inverting amplifier. So minus sign indicates 180-degree out of phase with the input signal. Plus sign indicates the output is in phase with the input signal. These are the references. So with this we have come to the end of the lecture. Thank you.